Welcome to this second Capital webinar. My name is Risto Örni. I work as a senior scientist at VTT Technical Research Center of Finland, and the topic of the day is ITS and CITS standards, testing and certification. So here you can see the agenda of the webinar. So we will start with a short introduction and ITS and CITS standards, and then in the second part we will have a case study on real-time traffic information. The case study will be presented by TISA, Traveler Information Services Association, and we will then continue with topics related to testing and certification. So first, what are the steps between scientific research and a functional ITS system? So sometimes the road from basic research to a functional system may be long. It requires validating a technology concept and developing a system prototype and validating the system in real operational environment. On the right, you can see the technical readiness levels that have been used to measure technological maturity of new innovations. And those technical readiness levels, they are relatively well defined for hardware and software. Then one needs a development model for developing an ITS system. So first, we have the V model that is relatively well known and established. The V model is based on first understanding the requirements and documenting them, and then starting from unit or device testing, and then continuing with subsystem verification and finally system validation. The V model is partially based on the waterfall model that starts from the user requirements and ends with a functional system. In addition to the V model and the waterfall model, there is also the agile development process. And in recent years, agile development methods have become more popular. And unlike the V model and waterfall models that put quite a lot of emphasis on documenting the subsystems and their requirements, the agile development methods put less emphasis on documentation. Then to standards. So first we need to understand what is actually a standard. So first, it's a set of mandatory requirements. On the other hand, it's established by consensus. And third, it's maintained by a recognized body to prescribe a disciplined uniform approach or to specify a product. And of course, it is also a document. And standards are not legally binding as such, but they may be referred to in government regulation or in private contracts. And what is important is that standards allow development of interoperability between implementations of the same system. And in this table you can see some types of documents that are prepared by CEN, European Committee for Standardization, and ISO, and also government that prepares regulation. Then we can look at the standard development process. So this picture illustrates the standard development process used by CEN, European Committee for Standardization. So the process of developing a new European standard includes several phases. It starts from a proposal that may come from anyone. After the proposal, a draft version is developed and sent for an inquiry to member organizations of CEN. After the inquiry, it will be either adopted or rejected by vote by CEN members. If the draft is accepted, the CEN Secretariat will prepare the final version that will be published by the national member organizations of CEN. And the expected length of this process is about 3 years. So it takes some time. On this slide, you can see some examples of ITS topics that have been covered by CEN standardization. At the moment, CEN has a technical committee for intelligent transport systems, TC 278, and at the moment there are 9 active working groups working under TC 278 and some working groups in dormant state. In addition to CEN, standards for ITS and CITS are prepared in Europe by ETSI, European Telecommunication Standards Institute. And the main focus of ETSI is in the communications aspect of ITS. And like CEN, ETSI has a technical committee working on ITS and CITS, ETSI TCITS, and the specifications provided by ETSI cover both technologies based on IEEE 802.11b and technologies based on mobile networks such as LTE vehicle to X, long-term evolution vehicle to everything. And so far, there have been 3 standardization mandates from the European Commission to European standardization bodies. The first one was in 1998 on road transport telematics, nowadays called intelligent transport systems. The second was in 2009 for standardization of CITS, including vehicle to vehicle, vehicle to infrastructure, and infrastructure to infrastructure communication. The most recent one was published in 2016, and this was mandate for standardization of urban ITS. For example, multimodal information, urban traffic management, and urban logistics. The standard development process of ETSI has some similarities with CEN, but there are also differences. In this table, you can see the different types of documents that are published by ETSI, and the different documents, they are for different purposes. And of course, the approval procedure is different for different types of documents. The approval process of a European standard EN, it has some similarities with CEN. Then to cooperative ITS, so different sources use slightly different definitions for cooperative ITS. And according to the European ITS communication architecture, CITS consists of 4 types of ITS stations: vehicle ITS stations, personal ITS stations, roadside ITS station, and central ITS stations that communicate with each other. However, the definition that is used by ETSI TCITS focuses mostly on vehicle to vehicle and vehicle to infrastructure communication. There is one more definition in the draft version of European Commission delegated regulation for CITS, and this definition requires also that the EU CITS security infrastructure is used. Then what are the applications of CITS? What are the CITS applications? So far, ETSI has defined the basic set of applications for CITS. And the basic set of applications includes 7 applications, and each of the applications covers 1 or more use cases. And in addition to the basic set of applications, also other CITS applications have been defined by ETSI, such as intersection safety applications included in ETSI vehicle to X applications. Some time ago, European Commission published a draft version of a delegated regulation for CITS. The aim of the delegated regulation is to create the minimum legal basis for deployment of CITS. And this objective is approached by providing technical requirements such as profile specifications for CITS stations, introducing regulations for putting CITS stations on the market in Europe, introducing regulations for putting CITS stations into use and maintaining them, and finally, providing regulations on the use of EU CITS security infrastructure. The delegated regulation also mentions a hybrid communication solution involving vehicle-to-X communication based on IEEE 802.11p and connectivity provided by mobile networks. Then we can look how the CITS will actually be implemented. So how it will be realized. So on this slide you can see an overview of the CITS protocol stack. In the bottom you can see the ITS access technologies. At the moment, 2 access layer technologies have been specified for CITS. ITS G5, including IEEE 802.11p and LTE V2X, long-term evolution vehicle to everything, which is an extension of LTE networks. The future releases of 3GPP specifications, third generation partnership project, will include also cellular vehicle to X and 5G vehicle to X. On top of the access technologies, there is the ITS network and transport layer, and for technologies based on 802.11p, the network and transport layer will include edge geonetworking protocol and basic transport protocol. In case of technologies based on mobile networks, the network and transport layer will include IPv6, TCP, UDP, or other transport protocol. The ITS facilities layer provides the basic messages that are used to realize CITS applications and use cases. For example, the CAM messages, cooperative awareness messages that are broadcast regularly by ITS stations, and the DEN messages, distributed environmental notification messages that are sent after a relevant event occurs. And on top of the protocol stack, there is the ITS application layer, including the CITS applications. On this slide, you can see an overview of LTE vehicle to X. So, in addition to the interfaces present in the usual LTE, there is also the LTE side link communication, which can be used to transfer data between vehicles or between vehicles and roadside units. In addition, the operator core network includes functionalities that are not present in regular LTE. For example, vehicle to X control function and the vehicle to X application server. So now we are ready to move to the case study.
Okay, thank you, Risto. So good afternoon. My name is Stephanie Chauveton. I've been working at Hertico as a project manager, and my main assignment in Hertico is the coordination of TISA, that stands for Traveler Information Service Association. So I would like to thank my colleague at Hertico for inviting me to this WebEx. So I will start briefly with the history of TISA. So TISA is a non-profit association established in 2007. This is hosted by Hertico. Here in Brussels, we have the office, and the TISA gave birth back in 2007 from 2 separate entities that looked at the same goals, which is to create maintains global standards for traveler and traffic information. So the TMC forum was hosted, coordinating by Hertico, and look at the TMC technologies, TMC standards, which is a specific application of FMRDS. It's used for broadcasting real-time traffic and weather informations. where data messages are received silently and decoded by TMC-equipped navigation system and delivered to the driver. The TPEC forum is a protocol, communication protocol for transmitting traffic and travel information. This can be carried via different transmission modes, and such as digital broadcast and cellular networks. So on the mobile project on the right-hand side, this is where the first prototypes of TPEC were tested in realistic driving conditions. So very important as well, global membership. Our main goal is to promote these technologies and to foster business. Just to give you a quick overview, global membership, we have today 90 organizations who are member of TISA. As you can see, there is a good balance of public and private organizations, cross sectors. And as you can see on the left-hand side, so the membership represents the whole value chain from content detection to event presentation. So, but the technologies that we are promoting are more focusing, of course, at the end of the value chain, where the information is presented to the driver. It's also very important as well, we do have cross membership and liaison outreach with various organizations. Artico ITS Europe, of course, who is one of the founding member of TISA, but also we are working, for example, with DATEX2 for the mapping of the safety-related safety sets with the ITS Directive Priority Action C. So, and also we are also discussing with the EUIP on particular topics, so where we see a need to discuss common interests, common topics, then we use these liaison activities. So, so TMC is a substantial business of members. And it's still growing in the market. So you can see here on the worldwide map, the blue countries is where you can find, you can have TMC services now available today. And in orange, these are countries where we foresee TMC services to be launched soon. Also in TISA, so we have standards that are linked to these technologies. It's under the ISO series 14819, and we have a dedicated group who is looking at the maintenance of the standards and also maintaining, also with the idea always to look at best practices and for better implementation. And this group is currently, now we have just a bit to ISO, a revision of those standards. Also link with the TMC technology. So TISA is doing some certification activities. Basically we are maintaining the worldwide database for TMC location tables. So the location referencing for TMC use location table methods, which has a set of predefined locations. So it's very essential that locations are identified, and we must ensure that this is encoding in the most suitable way and consistent way. And this is one of the reasons why TISA is performing certification of location tables worldwide, and this is perceived as a quality seal. So how we, so this certification is conducted by a small group in TISA. As you can see, we have a good balance cross-industry team with high expertise, service providers and map providers and navigation device manufacturer. And very important, they really look at to improve the quality of location tables, and very important and ensure that this is safely integrated into the maps. So we have, this is a service that is open to all. We do also offer for free a tool, a software to allow location table owners to pre-test the tables, so that gives them the full possibility to correct the tables if they have major warnings. And so the submissions is done via the website, and of course submission should comply to the existing specification and standards. And very important, confidentiality is a very key asset within this group. So now I would like to move to TPEC. This is the next generation coming after TMC. So it's a family of standards, and we call it a toolbox because you have various different variety of applications. So the transmission is language independent, and the bearer is independent and extendable. So you can create various traffic and traveler information applications. The first two applications were here on the slide show what these are oriented to traffic. They are the initial applications, and you can see also below these are other applications that we have been developed. So fuel price informations, electromobility information, and so on. So TPEC has a very important modular approach, so which means that when a TMC service has to be implemented or launched, the first two elements is, you can see the horizontal blocks or frames. So very important first is to make sure to install a message management container. So this contains the attribute of the message, the identification, expiring time, and cancellation, but you have also some options about the priority. And so the second frame is a location referencing container. So this supports various types of location referencing methods. So the method is chosen depending on the need of the client or the service provider, and it provides general information about where the content is related to. So as soon as you have these two frames installed, implemented, so it's easily to add. You can start with the most common TPEC application with its tech, as you can see, it's traffic event compact. And then at a later stage, it's easily to add those applications. It's like a plugin. In terms of coverage, as you can see, also similarly to TMC, in blue you can see it all the countries where we have TMC services running. So quite full coverage in Europe, USA, and China, and also deployments over different barriers: digital radio, hybrid, and mobile internet. So so now I would like to come to the process in terms of standardizations. So we have a category liaison with ISO, with a technical committee which is called the TC204, which means that we can intervene, we can liaise whenever there is a need. We see a possible overlap to discuss items. So the working group 10, this is the main working group in which we are submitting all the specifications for standardization. But if you can see, I put a few examples that when there is a need, for example, we are discussing with the working group, sub-working group 3.3, when it comes to alignment of location referencing. And also we had also some alignment on standards for cooperative systems with TPEC. So we have a dedicated ethical colleague who is the official liaison officer. So this is the person who is the representing TISA and preparing all the submission to ISO, and who is doing all the follow-up for the standardization process. So, and I wanted to show you on the right-hand side, this is a bit the process. You can see the interaction from on the right-hand side in orange, you have the process of TISA. So we are membership-driven organizations, which means that any ideas, applications that have been standardized or have been pushing through ISO, this is coming from our members' ideas. So it starts with the very specific idea. It's discussed within the membership, business aspects taken into account. We also check if there are no existing standards to evit any overlap of competition. And then the application is then developed within a dedicated working group. There are several reviews, And when the application becomes to maturity, then we push it to ISO. And you can see here on the left-hand side, the green column, this is the ISO phases from where we inform about the work item in ISO and the different interactions. So as in the moment, we have 20 TPEC 2 standards published through ISO. So I would like as well to share with you use cases that have been under development. Country-specific driving restrictions. This is an idea coming from one of our members based in China, where he provided a use case with Beijing about that cars with a typical certain license plate number cannot access the city on certain days. So very important that navigation system should take into account these road restrictions for better route planning. And so, of course, this is a use case for China, but it's also applicable for Europe. So we are looking now at how TPEC can take these all restrictions into consideration. We also had the use case for how to deal with a mix of manual and automated traffic when it comes to when you have on highways conventional vehicles and automated vehicles. And the last one is about to look at complex road geometries, for example, on toll gates. We believe that toll gates can provide a lot of information to the driver, and TPEC could be of support to help the driver to get to the right lane, but also for the future for automated driving, which lane are applicable for automated driving cars. So this brings to the end of my presentation. And very important, I would like to jump back on one statement that Risto you did in your presentation is about standards allow development of interoperability, and this is a very key and very important aspect, because this is why standards are for, to ensure that interoperability is there from the in the whole value chain. And very important, I think it's essential to liaise with organizations, associations to avoid any overlap or gaps, because at the end we all share the same goal. We must ensure that the end user gets the right information, and it has to be accurate and reliable, and the end user itself doesn't care about how he gets the information, but it must be right. And this is the goal we're sharing with everybody. Thank you very much for your attention.
Thank you, Stephanie. Many thanks for a practical example. And now we are ready to start with topics related to conformance, interoperability, and certification. So first, we need to define what is conformance. So a conformant implementation or a system satisfies the requirements described in a specification. And of course, conformance is verified in conformance assessment process that is described in the ISO IEC 9646 standard series, as well as in corresponding ITU, International Telecommunication Union recommendations. On this slide, you can see a high-level overview of the conformance assessment process. So the whole process starts with preparation for testing, and this includes preparation of documentation on the implementation under test, as well as collection of necessary documents like the underlying protocol and profile specifications and pro forma versions of documents and test specifications. And during the test operations, a static conformance review is carried out first. The static conformance review compares the features and characteristics of the system against the requirements documented in its specifications. After the static conformance review, the dynamic conformance tests are selected and parameterized, and the selected tests are carried out. Finally, a conformance test report is produced based on the results of static conformance review and the conformance log produced during the dynamic conformance tests. On this slide, you can see a summary of the different documents and activities related to conformance assessment. And before the conformance assessment can start, an abstract test suite is needed. It typically includes the test suite structure, the test purposes, and related test cases. In some cases, in which the implementation under test implements a specific profile, a profile test specification will also be needed. On this slide, you can see a summary of the conformance test suites for CITS protocols have been defined by ETSI. And all of these conformance test suites include the test suite structure, the test purposes, and individual test cases for the different protocols. Then to interoperability. So conformance is relevant because having conformant implementations increases the likelihood that systems or implementations will be interoperable. And a definition for interoperability has been provided by International Telecommunication Union in one of the ITU-T recommendations, and the definition includes both the ability to exchange information and the ability to use it. And the reasons why systems are not interoperable may be different. So first, there may be specifications that are incomplete, either intentionally or not. The existing specifications may allow too many options, or they may be specified in a way that is not so clear. Of course, sometimes systems are just implemented in a wrong way, and finally, sometimes there are systems that consists of a large number of specifications and or that follow a large number of specifications, and then there may be no one who actually has any coordinating responsibility of the whole system. So in those cases, one can say that there is a lack of system overview. Then to interoperability testing. So the process of interoperability testing is somewhat similar to conformance assessment. And on this slide, you can see a high-level overview. So first, there is a static interoperability review that compares the stated functionality of the system against relevant specifications. And after the static interoperability review, the dynamic interoperability tests are selected and parameterized. And then dynamic interoperability tests will be carried out, and the test results will be analyzed. Finally, a test and interoperability test report will be generated. And this documents both the results of the static interoperability review as well as the results of dynamic interoperability tests. And like in case of conformance testing, there may be interoperability test suites that include one or more test architectures, and each of the test architectures may have one or more related test cases. Then to system quality. So in addition to interoperability and conformance, ITS and CITS systems may also have other relevant characteristics that affect the usefulness of the system and the extent to which the system is able to answer users' needs. For example, this may be related to information quality or service quality. And for example, for advanced driver assistance systems, different reliability measures have been defined, such as true positive rate, false positive rate, and so on. And there may also be other quality attributes. For example, for real-time traffic information, a quality package describing quality criteria and assessment methods has been defined by the EU EIP project. Then to end-to-end testing. So in addition to conformance tests and interoperability tests, it is possible to perform end-to-end tests. And conformance tests, they usually focus on a specific part of a system. For example, implementation of a single protocol or one component or one element of the service chain. And interoperability tests may include one or more elements. But sometimes it is difficult to test all of the elements separately. For example, if there are no clear requirements for all the components of the service chain, or there are no clear requirements for all of the protocol layers. So in those cases, it is possible to test the end-to-end functionality of the system. And the advantage of end-to-end testing is that it covers the whole service chain, all elements and protocol layers if necessary. But its limitation is that it can tell if something goes wrong, but it does not always tell why. Then to certification. So on the one hand, certification is a written guarantee. On the other hand, it's a formal demonstration. And third, it's a process of confirming that the system complies with specified requirements and is acceptable for use. And on this slide, you can see an example of product certification process. So first, the manufacturer sends a request for certification to a certification body. And after the certification request, the manufacturer submits the product for testing to an authorized testing lab. Then the testing lab performs the tests related to applicable certification criteria and provides a test report. And based on the test report, the certification body adds the product to the list of certified entities and issues a certificate. So this model includes tests carried out by an independent test lab. On the other hand, certification of a product may also be organized as self-certification. And in the self-certification model, the manufacturer verifies that the product meets applicable requirements, and after carrying out the tests, prepares a declaration of conformity. The certification body may provide requirements for the product, provide recommendations on ways of verifying conformance, or maintain a list of certified entities. And the requirements for the product may be coming from regulatory authorities. They may come from standardization organizations or from industry stakeholders. So thanks for your attention, and I welcome you to the next Capital webinars. Thank you.